Great. Well, thank you everybody for joining today. We have a pretty exciting lineup, and I will admit, for me, this is very exciting because we at HOK, we use One Click, and we're always excited to hear more about what's going on there. So we are the Carbon Leadership Forum, the Toronto chapter. And I assume because all of you are here, you know how to get on. So I'll just skip those niceties. Let's see, go to the next one. We start with a land acknowledgement because we are a Toronto-based group. So even though it's virtual, we would like to acknowledge the land that we're meeting on. This is the traditional territory of many nations, including the Mississaugas of the Credit, Anishinaabe, the Chippewa, and the Haudenosaunee, and the Wendat people, and is now the home to many diverse First Nations, Inuit, and Métis peoples. And we also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. Thank you. So today, we are going to be learning about EPDs. And I love this title because it starts with EPDs. And I realize people who are joining this call know what EPDs are, but we use these acronyms and we just have to remember to say environmental product declarations so that people remember that. But today we're going to learn about EPDs, and we have Travis here, Travis Dahl. And Travis, actually, he hails from, I think, BC, I'm going to say. And you did a Bachelor of Technology in Construction Management, and you've been working in the industry for over 20 years. But over the last 5 years or so, Travis has transitioned into sustainability. And he's been working with a fair number of startups, solar development, and he is now One Click LCA's business development for the Canadian market. We also have with us Nick from One Click. Nick Gallardi is an environmental consultant, and he specializes in LCAs, life cycle assessments, and developing environmental product declarations, EPDs. And with his background in material engineering, Nick can analyze the environmental impact of products and processes to offer recommendations to become more eco-friendly and promoting a sustainable future. So thank you both for being here. And I'm going to ask that if you have questions, please put them in the chat, and we'll have questions at the very end. So we've got a presentation by One Click. And just before I turn it over to you two, just wanted to mention regarding the Toronto chapter of the CLF, we've been working on structuring the steering committee. And we're hoping to make an announcement on how we're structured, but we're always looking for topics and ideas. So please feel free to reach out to us if you have any ideas or things you'd like to hear about. We're always, we're open, we're here for you. We're here to make this change. And one last little thing with the IPCC, the recent report that came out, this is so important that we need to spread the word even more. So thanks so much, Travis and Nick. I'm going to let you guys take over.
Great, thanks, Susan. I'll go first. Basically, I'm just going to set the stage and line things up for Nick, who's going to close things out for us and really show us how this is done. But what I'll do is I will share my screen here. We can skip this first one, our title screen. Let's see. Susan already covered some of the housekeeping, but basically we've got this set for an hour. Nick and I were actually probably going to be speaking for about 45 minutes, well, including time for the Q&A. And as Susan said, like, send in your questions through, and we'll get to those at the end. It's obviously being recorded, and everybody's being muted for the presentation. If you want to check us out, we've got a couple of LinkedIn groups. First is our main company site, One Click LCA, but also we've got a user group where it's really just a community for everybody to support each other in the event that we've got a great customer service team, but if anybody's like slow to respond, or you're just looking for information, trying to figure something out, that's a great place to just engage with the community, and we're pretty active on there as well. But there's also great support from everybody else that's in the community as well. Just a couple of objectives that we want to hit for this session. So obviously, it's just a high-level introduction to EPDs, what they are. and then we want to get into developing EPDs and some of the rules and regulations behind creating an EPD and an LCA. And I should say, just in case anybody's coming from the architectural and engineering side, when we speak about LCA in this perspective, we're not talking about building lifecycle assessment. We're specifically talking about product lifecycle assessment. Just in case there's a little bit of overlap in terms that can get confusing when we're speaking about different concepts here. So for this, we're just speaking about products. And then, of course, to close things out, Nick is going to give us an EPD generation workflow demo using One Click software. But ultimately, the concepts are going to remain broadly the same, regardless of how you're doing it. So moving on, introduction into EPDs. Why do EPDs matter? Really, the broader picture is we're trying to decarbonize the construction industry. And how do we do that? We have to analyze every aspect of what's going into our buildings, not just from an operational perspective, which we've been focusing on for the last, say, 50 years or so. We've made huge strides on it, and there's still great progress happening. Toronto specifically, you guys have like a great ratio of, like, there's just been huge progress from the operational side of things. You've got a relatively decarbonized energy grid, but we really need to be looking at the broader picture and focusing on getting our total emissions down. No surprise, we're having some major impacts on global warming. So, and we're just repeatedly hitting record years. And why? So I guess I didn't really introduce the term embodied carbon, just in case anybody's not familiar with it. It's all of the carbon emissions that come from manufacture and production, transportation of the raw materials, and basically everything that goes into the construction of a building. And when we look at global emissions, looking at all the emissions that are related to the built environment, that contributes almost 40% of all global emissions. And when we look at the Canadian averages specifically, we break that down and we look at operational emissions and embodied emissions, and it's almost a 50-50 ratio. Obviously, some jurisdictions, I actually live in Calgary, so our operating emissions are quite high here since most of our electricity is still coming from coal. But in areas like Vancouver and Toronto, where the energy grid is largely decarbonized, it's heavily weighted towards the embodied emissions. So it's just as we continue to decarbonize energy grids and make our operational life cycles more efficient, the embodied side is just becoming more and more important. So producing LCAs and EPDs, there's the traditional way of doing it, which was very complicated and time consuming and cost a lot of money to get this done. But using various different softwares that can really optimize this process, we can really streamline that and just make it much easier and faster for everybody to get these done. And then, of course, there's a variety of different processes. There's tons of databases that we tap into, and just make it much easier to provide accurate information for your EPDs. Just a quick analysis, like obviously climate change is becoming a bigger issue, and it's being recognized by some of the biggest companies in the world, and really that's just what this slide is showing. Especially in the next 5 years, it's just becoming an increasing issue. This slide is a little bit complicated. I should have cut this one out. It's just a little bit messy, but ultimately what I just want to show is there's a bunch of charts and stuff. Like, there's a lot of different ways to analyze data, and the better we're able to consolidate all of this, it just makes it much easier to look at your products and materials and determine like where are opportunities to decarbonize products and different operations better, and maybe find holes in the market. There we go. Okay, so starting from the top, like, what is an EPD and what are the principles that they stand on? So ISO has defined the terminology and the processes of what an EPD actually is, and they've detailed it in these standards. And then the CN has taken those and created more stringent processes depending on where we're producing these EPDs. And a lot of these are the processes are detailed in a little bit more detail in these additional standards. And then we've got program operators. So ultimately, the program operator takes these standards and creates rules for a variety of different products. And so let's say we're talking about concrete. They create rules for how to follow that ISO standard and produce that EPD. And then once that's completed, it gets third-party verified, and then they publish it on their own database. The database that we use is EPD Hub. I should say not database, but the program operator that we use and recommend is EPD Hub. There are a variety of reasons for that. I'll let Nick, he may touch on that as he gets into this section. But ultimately, we want to make things easier and faster to get more of this data out there. Anybody that's working in the on the design side of things, you may have experienced frustration of just not being able to find data, and often it's just because it doesn't exist. But as we continue to really color in the landscape, it makes the process of building LCA much easier, and the EPDs are really the backbone of this process. So we need more manufacturers getting these done and just producing their data. So that's where this fits in. So from a high level, there's a couple of different. We're not going to spend too much time on the product carbon footprint, but basically it's just all it's doing is measuring what the carbon footprint is of a product. Whereas the Tracy system, anybody that's dealt with LEED projects, you may not be familiar with the term Tracy, but LEED draws on the Tracy database, and basically it looks at 6 additional environmental impact indicators like ozone depletion and eutrophication as an example, and whereas the other system just looks at carbon footprint. So these are important distinctions to make. With those 6 other indicators, we've got global warming potential, 6 total. Ozone depletion, acidification, eutrophication, which is nutrients going into waterways and causing algae blooms, and then smog creation, and then fossil resource depletion. So all of these are important factors for us to be measuring, not just global warming, but of course that's the most important one when we're looking at environmental issues. So what's changing in North America? There's quite a few policies happening around North America. Lots is happening in the US, and being a Toronto-based group, you're probably familiar with the Toronto Green Standard. But if you're exporting to the US or across Canada, in Vancouver, they've got a pretty stringent policy that's being stepped up this summer, and then again in the summer of 2025. Canada, at a national level, we're also planning on implementing a buy clean strategy, which is very similar to what they're doing in California and the rest of the US. So all of these things are going to have a huge impact. Just speaking about the buy clean strategy, like for any projects that are going to be federally funded for specific products, they're going to require not necessarily an EPD, but basically the way that the phrasing is they don't want to say like it must be an EPD, but that's going to be the best way to provide that data, that if they're going to be using your product in their project, it needs to have that information. One more noteworthy policy that was just released by the federal government December 31st. So basically it's started at the beginning of 2023, is the standard on embodied carbon in construction. And it's for projects that are using ready-mix concrete, relatively small volume. And the projects are valued at 10 million or more. And of course, this standard is becoming a lot more stringent in a couple of years, where they're cutting the project value down by half. So just something to be paying attention to. And this is going to be expanding beyond concrete eventually. It's just concrete is really the glaring topic when it comes to carbon emissions. And yeah, just some benefits about some of the different about producing EPDs. First one is being able to qualify for LEED projects. So one of the ways of getting points is producing building LCA for the project. And to be able to do that, the designers need to have EPDs available for materials that are going into these buildings. And then, of course, the second point is provided for showcasing improvements. So basically doing comparative analyses of different designs and showing that there's a certain amount of improvement between designs. Like I mentioned earlier, this is CFPs, or product carbon footprints, are very similar to EPDs. We're not going to spend much time on this. I just kind of want to introduce the concept. And of course, we can talk about this separately if it's interesting. But basically, CFPs are required for like anybody who's maybe putting products onto Amazon, for example, and you want to get the carbon-free certified, these sorts of things. This is where this comes in handy. And basically what it is it's a simplified EPD that only looks at carbon emissions. So it's kind of like a nutritional label that is missing all of the broken down like macronutrients, and it's really just showing calories. So that's kind of the concept behind the CFP. Moving on to EPDs, making the most out of your LCA. So let's just look at the definition of an EPD, and this comes from ISO. So it's an environmental product declaration and provides an independently verified summary of the environmental impact of a product throughout its life cycle, calculated through a life cycle assessment. So basically what we're doing is we're looking at a product that maybe it's coming from the mine or the forest, all the way from its earliest stages of the life through to the final stage of manufacture, transport to the construction site, and generally that's kind of what we're targeting. But we're also looking at replacement and repairs throughout the life, and then end of life demolition and recycling and these sorts of things as well. And then of course it does need to be verified by a third party. And like I mentioned with the product carbon footprint, where an EPD is a little bit more detailed, it's like that comprehensive nutritional label that also has the ingredients. Actually, Nick, you can correct me if I'm wrong, but I believe that the ingredients are not always shared, especially when it comes to proprietary products. But what we do need to know is these environmental impact indicators, and analyze the product based on that. And then a life cycle assessment, again, defined in the ISO documentation. So it's a life cycle assessment evaluates potential environmental impacts associated with the determined life cycle of a model for a process, product, or service. The LCA quantifies energy and materials required in specific value chain to calculate the corresponding emissions to the environment. So again, just kind of rephrasing that is we're looking at the energy and the materials that are going into your delivered product, and providing a quantifiable number for these. Digging down into this a little bit further, we've got a variety of different product stages. So I think a lot of people have heard the term cradle to gate. This has been floating around for quite a long time. Basically what cradle to gate means is cradle being the raw material extraction. So again, like the mine or the forest, let's say, and basically transportation and manufacturing through its various different stages to that final stage of manufacture, where it's being shipped from there to the construction site. So we're looking at these, and those stages are termed A1 through A3. So A1 is raw material supply, A2 is transportation, and A3 is manufacturing. And then we're also looking at end of life stage, as well as anything that falls outside of the system boundaries. So let's say it's solar panels and we're exporting some of the excess electricity back into the grid, that electricity would fall into that D category. But we are not looking at construction site operations or use phase operations. But cradle to gate with options, we can optionally select certain components of that middle section. And then cradle to grave, we're really looking at the entire life cycle continuum, including everything that can be analyzed through the life cycle of the product. Something that's also not noted here that maybe a term that you hear is cradle to cradle. And what we're looking at there is basically from this end of life, how much of those products are ending up back into new products and the construction stage. So ultimately, what we do want to get to is a point where we're recycling more and more and more of the products that are currently going to landfill. Again, these are just a couple of visual examples of EPDs produced through EPD Hub, but we can get more into that later. And so what we do at One Click is we have a couple of different processes. So there's pre-verified and non-pre-verified EPDs, and the best, I shouldn't say the best, the fastest way to get an EPD done is to go through our pre-verified partners. So going through EPD Hub, basically what they've done is they've already reviewed our software process and streamline and confirmed that okay, they accept this process. So when they do the verification, there's a lot less that they have to check. So it really speeds up that process. But you're not restricted. There's no reason that you can't go through, say, NSF or STM or one of the other program operators and get your EPDs done if that's desirable. And let's see. So I think I kind of covered this earlier. This was in that inverted triangle slide, but basically ISO and CN have defined what EPDs are and what they're supposed to look like, and then the program operator takes those definitions and creates general program instructions, and then product-specific category rules of how to actually perform the LCA for those individual products. And once an EPD is completed, it's good for 5 years. And here's just a little bit more, a couple of cuts from some of the ISO documentation that just defines what some of the how we're defining EPDs. Something that I didn't really note earlier is the declared unit, and so one of the things that does need to be shown in an EPD is the unit of basically the declared unit, which is how are we measuring this? So concrete would be cubic meter or cubic yard. Say glass would be by the square foot, it might be by mass. So ultimately what we're trying to do is create a standard for individual product types so that we can compare products against each other. Can you include more than one product in your EPD? Generally, yes. Each program operator has different rules around this. EPD Hub has quite a lot of leniency. Despite having extremely high standards, there's reasons behind this, but they have a lot of variation allowed for products that go into the same EPD. And then there's different types of EPDs. We can dig into this a little bit further, but ultimately there's sister EPDs where similar products are going in that might have say one product or one detail that's different, and these can go into the same EPD. We also have design phase EPDs. So if you need, let's say it's a new product where you don't have good background data, you can produce a shorter term EPD that's only good for 1.5 years, but you only need to produce a month of background data to get these done. And then there's project specific EPDs as well. These are often used in the case of, let's say, a specific concrete mix. I've been using concrete as an example a lot. Maybe I should pick a different product, but let's say a concrete mix is designed specifically just for a project and it's not going to be used anywhere else. That might be a circumstance where this type of EPD is generated. What is the cost of EPDs? It really depends. It varies on the complexity of the EPD, where you're getting it published, who's doing the work. But generally, they can range from say $12,000 to $30,000. I've heard as high as $80,000 for some products. It really kind of depends. Going through certain processes, like using softwares like ours, these can be done much faster, much more simply, and obviously at a huge cost advantage as well. Lastly, just a little bit about One Click in case anybody's not familiar with us. We're a software platform, not a software tool specifically. We've got a suite of tools that really integrate across the entire lifecycle assessment continuum. So ranging from helping manufacturers produce EPDs. Well, I'm actually going to touch on this in the next slide, but yeah, we're used broadly. We have a huge database of tons of different data points. Practically the entire global database of EPDs is in our database. We've got integrations for tons of different softwares, depending on what you're doing. We've got stuff that'll work for your process, and we've been around for a long time. So as I mentioned, starting with product manufacturers, because that's really the focus of this talk. We help manufacturers produce EPDs, but we also are, as I mentioned, we're collecting global EPDs. We basically scrape the internet for all the EPDs that are being published everywhere, and put those into a database to make them available for building and infrastructure designers to make it much easier for them to do their building LCAs and provide them with accurate data. And then from there, we also have greenhouse gas accounting tools as well, where these projects can easily be dumped into the GHG accounting, or if the firm is not doing building or anything like that, but they do want to be tracking their scopes 1, 2, and 3 GHGs, that can be done through our tools there. So from here, I'm going to pass it on to my esteemed colleague, Nick. He's our EPD expert on the team, especially for the North American side. And he's going to be able to speak at a much higher level and also show you really what does it look like to put together an EPD and produce one. So I'll hand it on to you, Nick.
Awesome. Thank you so much for that, Travis. I will start sharing my screen, and what should pop up will be an Excel sheet. So typically, we can import the data that you collected from an Excel sheet into our software. There's a few reasons for this, mainly because, and let me move this out of the way. Mainly because this is going to be a simpler route for you to parameterize any values or unitize or normalize any values that you get from your factory, from your manufacturing site, into that declared unit that you need it to get into. So I can be able to show you everything about this import Excel, and we will import this directly into the software, look at the database, and really pick apart everything. And from there, I can answer any of your questions. So from this layout, I have just chosen a simple product of a steel bar that's being made. This could be a railing, this could be extrusion fittings around a curtain wall. But for now, it's just steel that we will be working with. So that's kind of the idea that I approached throughout this. We can see that there are labels and boxes and columns for every single thing, and each one relates to what's going to be in the software. So from left to right, we're starting with what section are we going to be working in? What is going to be the doesn't necessarily have to be a material, but what's the resource for this, whether it's raw material, electricity, packaging. And in here you can put, so I have a few different examples. I have used what is an actual database name. So lubricating oil production would be an actual database name, as well as steel converter low alloy. This is what the database happens to be nomenclature wise. But I've also selected something a little bit different, which is just purely scrap steel landfill. You know, I don't really have a good idea for this. It's waste steel, it's scrap steel, and I know I'm going to landfill it. So let's see how good the software is with mapping that, and if not, can we map it ourselves and be able to find something that would be similar? And finally, going down, we have the transported mass, electricity, the recycling. This happens to also be another database name. And finally, the loads and benefits of it all. So let's start out. We know that we are a manufacturer producing this rail bar, and we just got some manufacturing data from us. Okay, it's going to be really hard to unitize it. So I'm going to go in my production volume, and I'm going to say, okay, I know that we produced this amount in this time frame of 12 months. And I need a declared unit of 1 kilogram as that's set by the PCR. Typically, your PCRs will say exactly what your declared unit should be. So I know that for this product, we're going to do 1 kilogram, and we produce about 100,000 kilograms of this product. And I just got some information from my manufacturer that the converter, this happens to relate to the raw virgin material. We ended up finding that 60% of all of that steel that was produced that year is virgin raw material. So I'm going to be putting 60,000 in here. And we will see in column G, or quantity, how that production volume from the other sheet affects this value that I will be inputting. And this is the key part of using this Excel, so that we can be able to parameterize and unitize it directly. And the reason it's doing this is because I selected yes here. So if I selected no here, and I had inputted 40,000 for the other remainder percentage of that steel. Now this is the recycled content. We can see that this is not it being unitized right here. So now when I change that, this is factory level data for that 12-month period. Now it will be, I put in one too many zeros, but it does get unitized from this way. And in the next cell down below, I have these grouped together as well. So this is another advantage of using Excel, is to be able to have a lot of this calculation done for you automatically. And I'm going to be looking for some EPDs as well really quickly. So I'm going to be putting a value in here as well. And on top of just getting your normal values, electricity data, manufacturing data, the amount that you produced, it's also key to get your production losses for that year. So on the right-hand side, I have about a 5% production loss for this. So I was able to parameterize this and relate my scrap steel landfill. This is my manufacturing waste of scrap steel. And I was able to bring in all these values together so that I can populate this on demand. And this would help make it easier for me in the long run if I have multiple products. Then at this point, let's say I have different steel railing profiles. Then it's just a matter of changing the values, importing this, and you essentially have a new EPD from there. So it can really speed up your process by this. Oops. And then finally, I have some electricity data in here as well, just to round it out. So this can either be from your installation, deconstruction. And finally, we're just going to recycle all of this steel and count for the benefits of that recycling of the steel, so that our product EPD or our product LCA can be able to harness those benefits of the recycling process. So with that, I am going to jump into the actual software, and we're going to import this directly. And we're going to see how well the software kind of maps all the different types of names that I had inputted to the region that I wanted, or to the actual product that I needed it to be in. So let me share my screen really quickly. And this is what your project design file will look like when you are starting in One Click LCA. So I have a steel demo right here, and I will be using our newest tool to use this for. So I will go down and I will import from an Excel file. I will now choose the Excel file that I want to pick from. Perfect. The steel demo is here. Now this is the process where it's taking everything from those columns. It is starting to look at it all. This happens to be a cautionary step right here. So this is making sure that I'm in the right project that I want to be. This is going to be in the right design that I want it to be. If not, I can certainly change it to another one. And if this is going to be the right tool, if I click the wrong one, I can certainly choose it again. And also, if I needed to have specific data points, then I could be able to do that. For now, I'm just going to select all data and let's keep everything open. From here, this is another advantage to the software as well. So let's say our manufacturing processes and data collection process happens to take a long time usually, especially if you're just starting out and it is not in your supplier agreement forms to get some of this data. It can extend the process. So let's say that you have only collected your raw material values and you have no idea about the electricity behind it. Then you would be able to use the add import to the existing data, where you can still work within that same Excel file and keep your raw material values in there, add your electricity, import that same exact file into the design that you want it to, and it will just add the electricity, even though you have the raw materials in there. But let's say even they gave you more information about the raw materials. That was the wrong year. We need to change those values. Then we can update all those values directly right away with that same exact import form. But for now, we're going to select with the default, replace existing data. And it will always pop up with, are you sure you want to overwrite? I have nothing in this file whatsoever, but this is just a cautionary step just to make sure that you are not overwriting in something that you do not want to. Here is where it will be classifying all the data points and what you would like to how you would like to classify some of these data points and how you would like to group them. The advantage to grouping is that when you map a data point to what you had named it in the Excel import form, it will recognize all the other names in the Excel import form that has the same exact one and put that mapping to all of those. So for now, I'm going to keep that selected and we will see if it had identified any that were similar. So here it is doing mapping, and we can see out of the 16 different data points, 15 of them have been identified directly by the software, and one of them has been unidentified by the software. So at least I like to go through them and make sure that it is aligning with what I would want it to be. So it looks like it is, all the transported mass and all the names are directly correlated to what they need to be. So that's great. Now for this one, this is the steel EPD, just to show you a little bit about the EPD database and what we can do with that. So for now, and what you can do with some of the other data points that are unmapped and you have no idea what would be related to that data point and you need some time to think about it, we can always decide later. Now I will, well, there's no need to save the new mappings, but once you have selected the new mappings, please save them and the software will start recognizing your, essentially how you name things and what it knows you will select for that data point. On the right-hand side, you can see how the mapping is being based. So a lot of it happens to be from global users and it understands that this is generally what's going to be selected. And it has recognized my type of wording and formatting where it now recognizes I'm going to be selecting this data point almost every single time. So this is my mapping choices that are being integrated at this point. And once you do more imports, it starts learning better and better about how you are coming across with your nomenclature to the database's nomenclature. Now from here, we are importing everything into the software. It is putting in all those data points, it's putting in all the values, the comments, transportation, and it's providing me directly to the results page. So from the results page, we can be able to see many different impact indicators, as Travis had pointed out. So we can use the EN standard, or since most of us are North American based, Tracy is really going to be the key highlight here. And we can be able to fully dive into the Tracy data points that we need to with the detailed list. And finally, for everything else, we can look at the output flows, the waste, and see where everything is going, as well as mass balance, making sure that all our inputs are balanced out by all of our outputs, and making sure that everything in has an out. Now let's look at how this data really looks like, and how well it kind of mapped all of this. So for now, I will go into the raw materials, and we can see that the only thing that I left unmapped is that steel EPD, and it has now turned it into an undefined material because there's nothing associated with it. So from here, now I can be able to identify and change it how I would like. So we can replace this, and with the different filters up here, I can be able to really select out of all of these data points in here. Let's see how many it pulls up right away. So we have, at least in some of these categories, about 20,000 just for ready mix concrete. So this is also generic data and manufacturer specific data. So that's a lot for me to go through with this one steel data point. So let's see, I'm based out in the US, so I'm going to select the United States, and I particularly want an EPD for this. So I'm going to be looking at an EPD, and yeah, I think that's good enough for now. Really, I just want to find a steel rail, really. So let's see what it has found. So there's no steel rail EPDs just yet, but there is plenty of steel-based EPDs from the US. So for now, I am just going to select this rebar up here with 60% recycled content. From here, we can be able to look at the product description a little bit more, see if this is appropriate. If not, we can go back and we can select another steel data point that might be more fitting for us. And if we do not want to select it right away, we can always look at this question mark right here to get a preview of it. So we can be able to look at it. And also for some that have a EPD attached to it, we can be able to download and view that EPD right away. So let me see about this one. No. So for this high strength steel, we can be able to look at it in depth. So I can be able to download the EPD right away, and we can be able to really look at what they had included, when it was issued, how long it's going, what is the validity period of it, and really look at everything else that they had detailed in their EPD. So that is an advantage where you can do this directly on demand. For now, I'm just going to be selecting this data point, and we are going to be mapping it to that undefined material that I did not decide at the time of my mapping. And now that we have the mapping in here, everything should be set. So from what I see, all the transported mass, the lubricating oil is in here. I can also look into this data point, and I can be able to see the different types of countries that it is associated with it. I just went with a generic one, so I just selected world for this case. And that is a little bit about how to use the software, how the import form really can help with that. And ultimately, with the creation of this design file that I was showing you, you can copy that, and let's say you have different profiles of steel rails, as I was going with earlier, and you wanted to have 2 EPDs, one separately for each rail profile, you can copy over this design file in One Click LCA and just change the value. So you can have them both side by side. And the advantage to that is you can be able to look at the graph side by side as well. So you can be able to determine and pick out from them what you really want to look for. Do you want things that are lower in eutrophication? Do you want things that are purely lower in global warming potential? You can really start balancing out all the different options and really look at a full scope of environmental impacts and try to make the best decision, because always, kind of like what Travis was saying with the nutrition label, we really focus on calories or the global warming potential, really. Well, sometimes it could be hidden with the fats, the proteins, and the carbohydrates, or the eutrophication, the acidification, and the fossil fuel resource depletion. So all of that together, we can be able to get a better scope of it and make better decisions, because sometimes purely looking at the global warming potential could limit our view on everything else with that. So with that being said, I really would love to open up the floor to any and all questions that you do have right now in this remaining time.
Great. Thank you very much, Nick. That was very thorough, and I'm actually a little bit afraid of to get started. And correct me if I'm wrong, Travis or Nick, I had put in the chat, I thought, where you got that Excel file from, but I may have be misleading people. So I was just going on the website and looking for that. But thank you. And also thank you for highlighting the importance of these other factors, not just the calories, but the eutrophication, these other impact categories. Now well, first we're going to start with the kudos. Paulina says that she can attest to the huge database on One Click, as well as the super friendly support staff. So we're going to start with kudos. And we then also had a question from Maru about, well, I think it was me who initiated that question by plunking in the lead 4.1 with those categories. But I did hear, Nick, you were talking about those different elements. And I'm wondering if you could just backtrack for Maru and maybe some of the people here on the call, when we're not just looking at global warming potential, maybe if you want to flush that out a little bit more, like what are those other elements? Thanks.
Yeah, so at least to even take one step further back, between Tracy and the EN 15804, there's a slight difference between some of them. So generally they do take in these factors. They'll take in global warming potential, acidification, eutrophication, but acidification happens to be the one where it is calculated differently. So let me quickly get a reference, just so I'm not mixing up the two. But let's see. For global warming potential, this is typically done by the IPCC standard, which is through carbon dioxide equivalence. So equivocating it to whatever a carbon dioxide molecule would be impacting on the environment. So typically methane gas is about 25 times more impactful than carbon dioxide. So that is being accounted for. If you have methane being produced from your factories, it's just being equivocated down into a carbon dioxide equivalent. For acidification, this happens to be, yes, for acidification in the EN 15804 standard, this happens to be based off of hydrogen molecules, whereas the Tracy one is based off of SO2. So at least the chemical basis behind it, or sulfur dioxide, based off of the chemicals that is working off of, they are different between the different impact categories. Mm-hmm. So eutrophication happens to be another one where that is phosphorus for EN 15804. and nitrogen for eutrophication in the Tracy standard. So usually it is based off of an equivalent of a chemical, carbon dioxide, nitrogen, and everything that might be similar that would be affecting the environment in that type of way gets equivocated to that base chemical. So if I think the global warming potential one is a great one because I don't know, that one feels more tangible.
It's more like the common denominator that everything goes back to, right?
Yes, exactly.
Right. Great. Now, when you were talking, there was a silly question I had. Now, we call it CFD, but it's called product carbon footprint. And why is it not called a PCF? And why am I so confused about that?
I think that one's defined in French, if I'm right. Like that, the actual name is French, so that's the acronym that we use. But
blame it on the French. Okay,
we
all
translate it into English.
And then stepping back, you had also something about the cost of what it costs to do an EPD. And you had on the screen $15,000, but then it could vary 30,000, 80,000 even. And if you could break down, does that include the consulting fees, or is there testing that goes in there? What more is included in that fee? What can someone expect?
Yeah, so that is comprehensive price. That's what we're generally looking at. So not including internal operations, but the hiring consultants and doing the analysis, going through the program operator to get the data published, and then third-party verification as well.
Okay, third-party verification. Okay. I see Maru has another question about asking how are these emissions measured? Oh boy, I don't know, Maru, if we want to go into that much detail, but
essentially the basis behind it is, let's say we are sticking with steel, and usually these impact indicators come from your generic data. So your generic data, let's see. Your generic data has a calculation already built in to essentially bridge the gap between your material and to these impact indicators. So for steel is essentially 1 kilogram of your steel being multiplied by what the generic data that EcoInvent had collected. What is the impact of 1 kilogram of that steel typically? And really it's just multiplying those two in order to get some of these values. Rinse and repeat with all the other data points that we had selected and adding, subtracting all together. That is how we're able to get those impact indicators calculated. Emissions wise, that happens to be a little bit more difficult with methane being equivocated down into CO2. That happens to be more based in chemistry and essentially how those chemistries are reacting between one another depending on the environment that you're looking at. So whether air, water, or land.
Well, thank you. Now I'm wondering if anyone has any more questions, and they were too shy to put it in the chat and they wanted to speak up and have a question with your face full on the screen. That's kind of being kind of funny. No, but well, that was an incredible walkthrough, and my mind is blown by just how much data is available on One Click. Now, just for the benefit of those who are on the call, do you have to be a member of One Click, or are these available if you just want to look around? And how does that work with One Click?
I can answer that. So if you are looking to use software from the building side, we do have free trials available for that. Due to the complexity, we don't have free trials for the EPD tools. But that said, if somebody does want to check out the database, we have a free tool called Planetary. You just Google One Click LCA Planetary. There's not our complete database, and it's just our North American database, but if you're registering from Canada. But it is pretty good. So it's pretty much all of our structural data is going to be in there. A lot of the envelope data, it's going to be things like partition walls and things like that that might be missing. But it's a pretty good database there. But when it comes to the EPD side of things, the best way to do it is to reach out and get a more detailed demo.
Mhm. Perfect. Thank you. Well, if there aren't any more questions, how would we get in touch with One Click if we wanted to have more information?
Yeah, you can either email me. I obviously didn't show the slide with my contact in it. It's my first and last name at oneclicklca.com. You can go to our main website and request a quote there, and that'll channel you through to me as well. For Nick, his email is structured the same, first and last name at oneclicklca.com. And yeah, you guys can reach out to us there or call us or just chase us through the website.
Perfect. Well, thank you so much for sharing with us. This is really important stuff, and we really appreciate what you're doing. And also, thank you everyone for joining us. We'll keep you updated on the next exciting thing that's going to happen. And for those who missed it, we're always looking for ideas. And don't be shy to reach out to us at the Carbon Leadership Forum Toronto chapter for things you'd like to see as well. So thank you, Travis. Thank you, Nick.
Thanks for inviting us.
Thank
Yes,
you.
thank you so much.
Take care.